Sa vlog na ito, ipapakita natin kung paanong ang calculus ay makikita sa ating pang-araw-araw na buhay. Ito ang realidad ng buhay ng isang inhenyero. A day in my life, kumbaga. Ito ang water tank, 8 meters above ground level. Ito ang tangke na nagsusupply sa amin ng tubig sa pang-araw-araw. Kailangan maglagay ng tangke dahil sa kakapusan ng supply ng tubig sa lugar na nasa mataas na pwesto. At dahil na din sa dami ng mga tahanan at establishmento sa paligid, humina ang pagdaloy ng tubig sa aming kinalalagyan. The tank is located, as I said, 8 meters above the ground. As you can see, my videographer is positioned in the roof of the garage located adjacent to the tank. We shall solve a calculus problem related to the design of the water tank, the time rates. Come, join me as we apply the concepts of calculus time rates in practical situation. The problem states, water flows into a vertical cylindrical tank at the rate of 1/4 cubic feet per second. The water surface is rising at the rate of 0.562 feet per minute. What is the diameter of the tank? Again, based on the problem, we have a vertical cylindrical water tank. The water flows to the tank at the rate of 1/4 cubic feet per second, while the water surface is rising at the rate of 0.562 feet per minute. We are going to solve for the diameter of the water tank. As we analyze the worded problem, the volume flow rate was given at 1/4 cubic feet per second, while the rate at which the water surface is rising was given at 0.0562 feet per minute. Let me correct that. 0.562 feet per minute. The rate at which the water surface is rising is 0.562 feet per minute. Now, we are asked to find the diameter of the water tank. Analyzing the given data and what is being asked, we may apply the formula for the volume of cylinder to solve the problem. Accordingly, the volume of the cylinder is given as pi divided by 4 times x squared times y, wherein pi has a constant value of 3.1416, x represents the diameter of the cylinder, and y represents the height of the cylinder. The rate at which the volume changes with respect to time may be represented by dV over dt as we apply concept of calculus. Thus, if we are to equate the rate at which the volume changes with respect to time with the differential of the volume, dV over dt is equals to pi over 4 times x squared times dy over dt. Further operating the algebraic equation, we substitute the given value of volume flow rate with dV over dt, which is 1/4, and 0.562 for the value of dy over dt. The given volume flow rate has a unit of cubic feet per second, while the rate at which the water is rising is 0.562, which has a unit of feet per minute. Then we shall have the equation. 1/4 is equals to pi over 4 times x squared times 0.562 divided by 60. Since the volume flow rate is in terms of cubic feet per second, while the change in height with respect to time, or the rate at which the water is rising, is given in minutes, we have to convert the values by dividing the rate at which the water is rising by 60, because for every minute we have 60 seconds. Operating further the algebraic equation, we shall have x squared is equals to the quantity 4 times 60 divided by the quantity 4 times pi with a constant value of 3.1416 times 0.562. Then we shall operate further the algebraic equation, giving us the equation x squared is equals to the quantity 4 times 15 divided by the quantity pi times 0.562. This leads us to the equation x squared is equals to 34. Thus, if we are going to find the value of x, it is equals to the square root of 34. Finally, we have arrived at the answer. X is equals to 5.83. And remember, we represent the diameter using the variable x. Thus, the answer to the question, what is the diameter of the tank? It is 5.83 feet. Using calculus, we represent volume flow rate, or the rate at which the water is flowing, as dV over dt, which is equals to the differential of the formula for the volume of vertical cylinder, where pi has a constant value of 3.1416, x represents the diameter of the tank, and the rate at which the water is rising is represented by dy over dt. This leads us to the determination of the value of x, representing the diameter of the tank as 5.83 feet. That ends our blog for today. I hope you have learned something from this. As applied in the design of water tank, we have solved problem on time rates.
So that's all for today. This is Dr. Ram at your service.
Thanks for watching. See you on my next vlog.